Modern programming often feels like drafting a legal contract. You dictate every step to the machine, using hundreds of English-adjacent words to move a single piece of data from one location to another. But in the 1960s, a different approach emerged. APL, or a programming language, replaces paragraphs of text with a tight mathematical shorthand, representing complex operations as single Greek letters and geometric glyphs. You don't read APL like a recipe. You observe it as a sequence of distinct visual actors performing logic. A dozen lines of standard code collapses into a single string of symbols. To understand how it works, imagine the computer's memory as an empty geometric plane. This is the shared space where these mathematical actors arrive to do their work. The first to arrive is iota. Iota is the index generator. It counts, laying down a sequence of numbers outward from the origin like a series of steps. 1, 2, 3, 4, 5. To hold that sequence, we use the left arrow. This symbol is the keeper of names. It takes the numbers iota generates and provides a permanent home for them in a named variable. Then there is ZILD. ZILD is the empty numeric vector. It isn't an error or a missing value. It is a shaped emptiness, a zero that is aware of being a zero. Writing an APL means setting these distinct behaviors onto a shared plane and letting their geometric interactions define the logic of the program. As data grows, so does its architecture. In APL, this is defined by rank, the number of axes a thing extends along. A 1D list is a vector, a 2D table is a matrix. The symbol up, or mix, acts as a structural inhale. It gathers separate one-dimensional lows and unites them into a single two-dimensional grid. The symbol down, or split, is the exhale. It releases the matrix, returning each row to its own independent one-dimensional rank. In contrast, epsilon ignores these walls entirely. It reaches through every layer of a nested structure, dissolving boxes within boxes until only a single flat line of the raw contents remains. Every operation on an array forces a choice between prioritizing the structural arrangement of the data or the simple sequence of the items contained within it. Eventually, the plane accumulates disordered data, numbers and letters tumbling over one another in a chaotic sequence. To find order, we use ELF, grade-up. It acts like a scout, reading the chaos and returning a map of indices. These indices tell you exactly where to look to pull the data into an ascending sequence. But sorting isn't the only way to organize. Sometimes data is better understood not by its rank, but by its kinship, which elements belong together. This is the function of pi, the key. It recognizes every identical element in a sequence and gathers them into groups. It looks at a word like Mississippi and identifies its families, 1 M, 4 I's, 4 S's, and 2 P's. While grade up tells you where each thing belongs in a line, the key identifies which things were already related in the first place. The most complex action on the plane is recursion, a function that calls itself to solve a problem. Nabla, is the symbol for this descent. It looks like an upside-down mountain, a cup meant to catch its own output. When Nabla calls herself, she steps down into a new version of her own thought. She passes smaller and smaller arguments down through these levels, layer by layer, until she finally hits the base case, the logical floor where the answer is simple enough to return. Reaching that floor triggers a chain reaction. The answer bounces back up, resolving each suspended level in a single upward motion until it reaches the surface. Infinite depth is managed through this architecture, a series of suspended rooms that only complete themselves once the floor has been found. If you pull back from the philosophical plane, you eventually reach the physical architecture of the machine itself, the bedrock running the code. That bedrock is I-beam, the I-beam. It is a load-bearing symbol, a structural switchboard that existed before the rest of the language learned to stand on its own. By calling the I-beam with specific legacy numbers, you reach through the plane into the system infrastructure to retrieve core data, like the current time or the software version. Finally, there is LAMP. This is the comment symbol. It executes nothing. It only illuminates, casting light on the surrounding logic so that a human reader can understand the purpose of the symbols. Coding in APL is an exercise in geometry. a process of finding the specific symbol and the exact distance required to bridge the gap between a question and its answer.